so let's talk about the chair. So what is the chair? The chair is just the most stable conformation of a six-membered ring. Okay. So because remember, when you have a cycloalkane, specifically we're talking about cyclohexane in this case, it will kind of move itself in nature and will kind of go into that boat formation and will kind of twist and contort until it can get into the most stable or lowest energy conformation. And when it finally arrives at the chair, that's where it's at its lowest energy conformation. You could look at an energy diagram to really see that. And there's two different sides of the chair, and we're going to talk about that a little bit. So just to show what the chair looks like, or I should also say, well, so we'll start by drawing the chair. So there's lots of different methods to draw it. I like to break it up by starting with this V. Then I draw this extra arrow, or this extra line down here. Then finally bring it not quite to where I started. And then I'll go back to the starting point, draw another diagonal line, and then close it up. There's lots of different ways to do it. That's just the way that I do it, the way that I draw it. So then, as far as the substituents are going, well, and actually, let me even back up just a little bit here. So if I have this cyclohexane, I'm just going to flip it into the chair here. And so at each one of these positions, which I'll number here I'll number 1 through 6, we have this chair, and remember at each one of these positions there's just going to be 2 hydrogens. And I'll number here so we can see it corresponds. So we'll draw in the hydrogens. Now when you have the chair, there's two different positions. You have equatorial and axial. So I'm going to label those in different colors to really make them stick out. So you have 6 axial, and then you have 6 equatorial. So we'll start with drawing the axial positions. So when you're looking at the chair, you're either going to be saying the substituent is up or down. And it starts, I always start right here at 1, where the axial position is up. Okay, and if the axial position is up, that means the equatorial position is down. And then it just alternates. So when you get into position 2, the axial position is down, and the equatorial position is up. So, as you can imagine, when you get to position 3, axial is back up, and equatorial is back down. So this is, here it's a little bit tricky to make that distinction, so it's, to see it at least just because of the way the chair is drawn. So then once we get over here to position 4, we've got the axial back down, equatorial up. Over to position 5, axial up, equatorial down. And then finally, axial down, equatorial up. Okay, so the way that I like to think of it is up, down, so up, let me keep going right. I just think of it as up, down, up, down. And so I'll start by just looking at all of my axial positions. So I say up, down, up, down, up, down. So, and then I just go in and fill in the equatorial and the opposite, because there's going to be one substituent that is up, and one substituent is down. If the axial position is already up, the equatorial must be down, and vice versa. Okay, let me erase this, because we can also flip the chair, which will invert the substituents. So what was once equatorial is now axial, and vice versa. Oop, I'll get a big mark. So to draw the flipped chair, instead of starting my second line from right here, I'm going to start it from the other side, and I'll just draw kind of in the opposite way. So there's our flipped chair. Now a really key point that I really want to emphasize is this position right here. This position which I've labeled number 1. When you flip the chair, your number 1 position moves from here to right here. Okay, and so with that movement of position 1 to there, that just renumbers everything. So it doesn't really make as big a difference right now because all we have are hydrogens, but when we do the first example, it will make sense, more so. And so, but then again, we have the same thing with axial and equatorial, where if I start here, I'll start with axial because that's what I usually do. You have up, down, up, down, up, down. And then I just go in and fill in with my equatorial. Down, up, down, up, down, up. Okay, so that's the chair and its flipped. So that's kind of the general way. This will make a little bit more sense once we do an example. So let me erase what we have here. Okay. So if the question, so a really common question, something like,